Good morning, class. We'll continue with chapter 2, which is an overview of NoSQL. Actually, the basic NoSQL I already covered in the first chapter if you refer back my first video. But here we will see a bit more detail about NoSQL part. Okay, by end of this lecture, you will be able to define and describe what is NoSQL database are, understand the reason why NoSQL database are used in modern applications, identify and categorize different types of NoSQL databases, write some basic queries, and differentiate between relational and non-relational database through an examples. Okay, so the content is very simple content, only very small chapter defining NoSQL, why NoSQL, and list of NoSQL database. Defining. Definition: NoSQL is not only SQL, refers to the class of non-relational database management systems designed to handle large-scale unstructured or semi-structured data. Unlike traditional relational databases, NoSQL databases do not rely on fixed schema or tables. As you know that in normal SQL database that we have learned, there is a schema like ERD diagram. There is a data model. We will create a data model which will be referred for the throughout database development process. But for this one, for NoSQL cases, there is no any specific or fixed schema or tables. Okay, so that is the best part of NoSQL because they are mostly work on, okay, this is the highlight. They mostly work on large scale, unstructured and semi-structured data. But when it's come to normal SQL, if you notice that they will mostly work on structured data. Okay, so the key characteristics, there are 4 key characteristics. Number 1, schema-less design. Number 2, horizontal scalability, scaling up across multiple servers. Number 3, you can see here flexible data models. And number 4, high availability and fault tolerance. You will see that detail of each of these characteristics. Okay, schema-less design. What does schema-less design means? In relational database, schema is a structure of data. It is predefined and rigid. For example, table must have a fixed number of columns with a specific data types. For example, we know about metadata, right? Okay, when it's come to metadata, we have a table. So for example, you have a student ID. So this student ID, it can be text or like a varchar. Okay, so it's based, we already fix it. In contrast, NoSQL database do not enforce a strict schema. Each record or document can have its own structure, allowing for flexibility. Okay, this is the important keyword here. Flexibility in how data is stored. That is the best part of NoSQL. There's no any restricted schema and it is very flexible. Why is this important? Dynamic data. Modern application often deals with dynamic or evolving data. So for instance, user profiles in social media app may start with basic fields like name and email, but later expand to include additional details like hobbies and preferences. So when the data is grow up, so we can add the data without any issue with the table. Okay, in structured data, for example, like in normal relational databases, when you want to modify the structure, it might cause some issues. Okay, if you are not properly modify or alter the table. But when it's come to NoSQL part, it's totally different. So you can just modify, maybe like first row they can have like 2 columns. Second row or second document or second data records that we have, they can have like 3 columns or 4 columns. So you don't have to be like schema. This is why we call it schema-less. Next example, you can see it here. We can see from this example, in MongoDB, a document store, you can insert document with different fields into the same collection. For example, we have a database users, insert 1, name Alice, and age is 25. So this one is first record, and this is the second record. You can see here, database user, insert 1, name Bob, city New York. So here the name is the same, right? The column is the same, but the second column you can see, one is age, one is city. So the first document has age, and then the second document has a city field. Both are stored in the same collection of database without any conflicts. So this is what we call as flexibility when it's come to NoSQL. Second point, horizontal scalability. What is horizontal scalability? Horizontal scaling refers to adding more servers, nodes, to distribute the load and increase the capacity of the database. In contrast, vertical scaling involves upgrading a single server, adding more CPU or RAM. Why is this important? In big data, NoSQL databases are designed to handle massive amounts of data, okay, by distributing it across multiple nodes. We have backup, right? So for example, this is a database A, and inside they have a multiple nodes. So we have B. So 1, 2, 3, 4. The same thing, sometimes it will be stored here, 1, 2, 3, 4, and so on and so forth. So same data present in multiple locations, okay, same data 1, but in different location A and B, you can see. So this is what we call as distributing across multiple nodes. So it's cost effective. Adding inexpensive commodity hardware is often cheaper than upgrading expensive high-end servers. Okay, this one will be more costly compared to upgrading the commodity hardware. Fault tolerance. Distributed system can continue operating even if some nodes are failed. If some of the nodes is failed, it's still able to work with that particular system because it's still able to grab and retrieve the information or data from another node. For example, Apache Cassandra is a column family NoSQL database that supports horizontal scalability. If your application grows from handling 1 TB data to 10 TB data, you can simply add more nodes to the cluster without downtime. See, so this is the horizontal scalability, the importance of horizontal scalability, because it's working with massive amount of data. Remember, most of the NoSQL, it's working with unstructured and semi-structured data, which is come from big data, massive amount of data. What are flexible data models? Okay, the third characteristic is flexible data model. NoSQL support various data models, include key value, document, column family, and graph base. Okay, why is this important? Diverse use cases. Different data models cater to specific use cases. For example, graph databases are ideal for social networks because it's come out with the networking, right? From here to here, here to here. So we can have a multiple networks. So it's like a graph connecting to each other. And adaptability. Developers can choose the data model that best fits their application's requirements. So that is why we call this a flexible. So based on their scenarios and requirements, they can adopt these particular data models. Example, a key value stored like Redis might be used for caching session data. A document store like MongoDB could be used to store blog posts with very metadata. A graph database like Neo4j could be used to model relationship between user in a social network. So these are some example of flexible data model. And the last characteristics, which is high availability and fault tolerance. Fault tolerance means you try to reduce as much as error as possible. So what does high availability means? NoSQL databases are designed to ensure that the data is always accessible, even in the event of hardware failures. If there is a failure, as I told you before, okay, you can see here, if there is hardware A is failure, okay, they still can access to B. If B is failure, there will be multiple another place where they can find out the data. So this is what I call as fault tolerance, where you can get the available data. So they achieve this through technique like replication and sharding. So this is what I mentioned about replication. Replication is a copies of data that's stored on a multiple nodes. If one nodes fail, another can take over seamlessly. Sharding, data split across multiple nodes, shards, and this ensures that no single nodes become a bottleneck. Why is this important? Mission critical application system like e-commerce platform or financial services cannot afford downtime. For example, like Shopee and Lazada. If there is a downtime, obviously it's a big loss for them, right? So they cannot have this kind of downtime. So they have this kind of high availability and fault tolerant database. Okay, types of databases, NoSQL databases. The first one is key value stores. Okay, what is key value store? A key value store is the simplest type of NoSQL database. It stores data as a collection of key value pairs where each key is unique and maps to a value. Key and value. So the key map to value. So that is what we call as key value pairs. The key characteristics, simple data model. Each record consists of key and its associated value. They must have a key and they must have a value. High performance, it's optimized for read and write operations, which means you can save data and you can load data. Use cases, caching systems, session storage, and configuration management. Example of these key value stores, it's come from Redis remote dictionary server. Is an in-memory key value store often used for caching and a real-time application. Okay, the basic syntax. Set value, get key and delete key. Imagine you are building a web application that needs to store user sessions temporarily. For example, you set a session called 12345 user data and the session name is user data. So you set ready. Set means you fix it and you save it. The session. Okay, after you set, you need to get the session. In order to retrieve the session, you just to use keyword called get session with the session ID. So the output will be user data. Okay, so the set commands here store the user session and get command is retrieve the session data when needed. Okay, second NoSQL type database is actually document stores. What is a document store? A document store organizes data into semi-structured document, typically in JSON or BSON format. Each document can have a different structure, making it highly flexible compared to relational databases. Okay, the key characteristics again for this one, it's flexible schema. As I told you, relational databases, we usually have ERD. But when it's come to NoSQL, we don't have to follow this ERD. You can modify at any time, at any place in the database. Rich querying, support complex queries on nested fields. Okay, like queries inside a query. Use cases, content management system, catalogs, user profile. We'll see how to do this coding and all these things. Okay, example that document oriented NoSQL database is actually a MongoDB. Basic syntax, database collection dot insert one, we insert the key and value. Query document database dot collection, find the query name. Okay, so example, you're building an e-commerce platform and need to store product detail. For example, step number 1, insert a product document. Second step, okay, first one, you just insert product record, name wireless headphones, price is 99.99, category electronic, stock 50. So there are 4 columns, which means 4 records are there. I mean, 1 record, 4 details are there. Step number 2, we want to query the product in the electronic categories. Okay, so we just select category called electronic. So the output will shows you name wireless headphones, price 99, category electronic, and the stock is 50. So insert one method adds new product to the product collection, and find method, you can see here the find. Okay, find method retrieve all the products from category called electronic. So this flexibility allows you to add more new fields to document without altering the entire schema. But when it's come to relational database, you have to modify the schema itself. But in MongoDB NoSQL scenario, you don't have to do that. They are very flexible. You can directly modify from the structure itself. Third database is a column family stores. What is a column family store? Column family store organize data into rows and columns, but unlike relational database, columns are grouped into families. Okay, these columns are grouped into families. This design is optimized for handling large data sets and performing analytical queries. The characteristics are column-oriented storage. Okay, data is stored by column rather than rows. So you know what is rows and what is columns, right? So this is what we call as rows. This one is known as columns. They say it's stored in columns. Scalability, designed for horizontal, again horizontal scaling, okay, not vertical. And use cases like time series data analytics and IoT applications. Example is Apache Cassandra. Apache Cassandra is distributed column stored, known for its high availability and fault tolerance. So we create a table called table name. Okay, this is the basic syntax. Insert into the table, select star from. It's look like normal what we call this SQL that we have come across last semester. So create table, got sensor data, device ID as a primary key, timestamp, temperature, humidity. Step number 2, insert sensor reading. So we insert record, and step number 3, we want to retrieve the record that we have insert into sensor table. Example of NoSQL queries for key value stores, you can see on your Redis. Okay, insert set command and get command. Okay, set John Doe and then user is 1000. The syntax for MongoDB. Okay, this is two different example of platform. One is MongoDB, the other one is Redis. Okay, when it's come to insert and query documents, you can see here for users, insert Alice, age, city. The query, just find city New York. So it just return all the output which is come from the city New York. So this example, I guess you guys, this one is another example of database which is Neo4j. This one is more to graph based database. Okay, so this is all about NoSQL overview. So we already learned about definition, advantages, types, and then some examples. Hope this one more or less give you some idea about NoSQL databases, their characteristics, and also some example of how the the NoSQL commands are look like. Okay, after finish watching this video, I will share this question into author assessment as a chapter review question. So I want you to do it and submit. That's all. Thank you.